right, welcome back. We are going to talk about solving literal equations today. Now, just a reminder from our last discussion, literal equations are equations that have multiple variables. So these don't have just an x or just a y. These have multiple variables. So like x and y, or multiple letters. So here's an example of a literal equation. This is actually called standard form for linear equations, which we will get to in a couple chapters. We've got ax plus by is equal to c, and we're going to solve for the value y. So all this means is that I want to isolate y. I want to get that by itself. So just like when we were solving equations, we're going to move whatever is adding or subtracting, our constant, which is not really a constant in this case, but so what is adding or subtracting? We always undo that first, unless we have a special case. So since ax is adding to x, or to y, I'm going to subtract ax from both sides. That here then leaves me with by equals c minus ax. Okay, now still trying to get y by itself. The b is still there. Now what operation is the b doing? It's multiplying. So in order to undo that multiply, I have to divide. Now when I go to divide this other side, I'm going to divide everything. So I get y is equal to c minus ax over b. Occasionally you'll see a problem like this where they do c over b minus ax over b. But for our purposes, this right here is what we're going to write. Okay, I've got 3x plus 6y equals 12. And this time I want to solve for x. So first thing I need to do is move what's adding or subtracting. So in this case, we're going to subtract 6y. So I get 3x equals 12 and 6y are not like terms. So I get 12 minus 6y. Okay, and our last thing here is we need to divide. And we are dividing everything over here by 3. Now I could stop there, but since 3 does divide out of both 12 and 6 evenly, I am going to split this one up into the two parts. When we're dealing with linear equations, it's nice sometimes to go ahead and split those two parts up. So 12 divided by 3 is 4. 6 divided by 3 is 2. So we end up with x equals 4 minus 2y, or I could say negative 2y plus 4. All right, let's look at another one. I've got 2x minus y equals 5. And I want to solve for y this time. So again, first thing I want to do is move what's adding or subtracting. So we're going to move the 2x. And since 2x is positive, we're going to subtract it, leaving me with negative y equals. So remember when we're moving the constant term or the term that's adding or subtracting, we always do the opposite of the sign that's in front, not the sign that's after. All right, 5 and negative 2x are not like terms, so I'm going to do negative 2x plus 5. I could also write this 5 minus 2x, but it's nice to get in the habit of putting that x term first. All right, the y is still not by itself. Oops. So, what invisible number is in front of y? Negative 1. So I'm going to divide everything by negative 1. So we get y is equal to, well, negative 2 divided by negative 1 is 2. 5 divided by negative 1 is negative 5. So my answer is y equals 2x minus 5. All right, we're going to look at another one. I've got 5x minus 10, y equals 30. And again, this time we're solving for y. You are going to find when we're given a standard form equation and we're asked to solve for y quite often. So first thing I want to do, move the x away. So minus 5x, leaving me with negative 10y equals negative 5x plus 30. Then since the 10 is multiplying to y, we have to divide everything by 10. So I get y is equal to negative 5x divided by 10 plus 30. Oops, that's a negative 10 divided by a negative 10. Well, 5 doesn't divide by 10 nicely, but both are divisible by 5. So 5 over 10, sorry, negative 5 over negative 10 gives me a positive 1/2 x. And 30 divided by a negative 10 is a negative 3. Okay? All right, now let's look at a different form. So we're given d equals r times t, and we want to solve for r. Well, we have nothing adding or subtracting, so we don't have to worry about any of that. But we do have something multiplying, and in this case, it's the t. So I'm going to divide both sides by t. So that gives me on this side, d over r is equal to t, or t equals d over r. All right, one final one. I've got area equals length times width. Okay. And this time they want us to solve for L. Well, we're looking, the W is multiplying to the L, so we're going to divide both sides by W, leaving me with A over W is equal to L. All right, that is it for this video. We'll talk about a few more in the next.